Hi everyone, we are Doctech Limit. It is our pleasure to present our startup based on the tissue project entitled Electroplating Thin Bismuth for Low Temperature Soldering Application. As shown in the figure, the number of connecting devices has already exceeded the world population in 2013. It is clear that the connecting devices reached over 20 billion after the end of 2020. Therefore, there is a strong demand to increase the computation power. It also triggered the request to have a smaller and faster transistor. So how? High-density devices and 3D IC chip is a solution. It is a scheme for current advanced electronic application. There are some key challenges are showing. In order to satisfy the required property of the local interconnect, RDL, and copper pedal, basically, copper layers are critical for different applications. Moreover, in the current market, best platform and competitor can provide a solution for various problems since it will be expected that whole process requires the temperature stable and strain stable to achieve no self-annealing effect of copper and maintain its inherent property. Another issue is that the development of low-temperature soldering, so-called LTS process, as landmark showing, is quite important for current IC packaging. So our business opportunity is that Doctech can provide the solutions and platform for this different scenario. Here, our core technology is that we can fabricate a series of copper structure by controlling the ratio and distribution of nanotwin and nanograin in electroplate copper, and we have built up the systematic test and demonstration. This part is the motivation of development of low-temperature soldering process. Current 3D IC chip staking is adapting lead-free soldering process. So chip and substrate are required to satisfy the temperature range around 220 to 260. So the higher temperature capability of material should be concerned. It might have to pay more material cost. Another issue is warpage of materials that induced by mismatch of thermal expansion coefficient during higher process temperature. So LTS process can provide low soldering temperature and decrease the effect of warpage. Here we are conducting the development of thin bismuth alloy soldering. Theoretically, thin bismuth alloy microbond for low temperature soldering has the metric, including the lowest eutectic point at 139, good dry strength, low surface tension, and good anti-corrosive property. So how to control the deposition by electroplating thin bismuth on copper micropedal has some advantage like low cost, scalable production, and easy to handle as from. IP is another important part in our company. In RDL, we developed an additive for nanotwin copper with accident superfeeding property without self-annealing and grain growth even after heating. In micropedal, to develop the impurity inhibitor additive to form defect-free interfaces and less candle effect between copper and soldering. Moreover, copper-to-copper direct bonding appears to be a solution to solve the problem of draw heating and electron migration. Therefore, how to control of copper structure to reach a highly stable and high mechanical strength to satisfy the requirement in copper-to-copper bonding is very important. Here, this is our initial milestone for tissue second year. In first quarter, we will prepare the collecting agent by after material fast screening of thin and bismuth. In second quarter, we conduct electroplating by 1 or 2 step method to achieve cold deposition of alloy. In third quarter, under our optimization condition, we can prepare stable electrolyte solution. And final product, we aim to achieve the temperature less than 200 for pin-based soldering micro bond and deliver the parameter optimization of electroplating. Thank you.